And in this clip, I want to show you a little bit about how to both tune your mesh and to inspect your mesh. One of the tools you have available here is up here at the top for the section planes. And you can see down here I have a toolbar that says section planes. And I can come in, and let's orient normal to this, and I can draw a line. It's going to draw this relative to whatever face we have. And it's not perfectly straight, but that's going to be all right. Here it's defined as section plane 2. And with that selected, I can come here and click on Edit Section Plane. So now it gives me this toolbar where I can drag this, and it's showing just an individual plane. Or I can click on here and I can show one side of it. And you can see as it goes through, you can see the elements. We could zoom in on that. You see there's brick type elements, and the stresses are pretty uniform. The shapes are nice and straight. That's one of the advantages of these, is it makes for uniform shapes. If I click on one side, it's toggling whether it's showing just a plane or that side. I can click on here and drag it back and forth. Right, and if I want to click on the other side, I can click over here. I double click, it just shows me an individual layer. So I can scan through there and see there. And it's fairly uniform, and it's a pretty good looking mesh arrangement. And it does take a pretty fine mesh in order to get a good resolution around this with the brick elements. All right, so that's one tool. And of course I could come over here and select define a new section plane and cut the other direction. And you can see you can have two of them operating simultaneously. So I click on this and edit section plane, and now I could drag this up and down where I'm cutting, and click over here, drag this left and right. But say I don't really want to see both at the same time, I can just unclick that one, and now I can see here. Let's go ahead and edit section plane, so I can see my stresses. You know, that things are pretty uniform along there. Okay, so that's one way of looking at the mesh. Now, if I come back here, I want to point out a couple of parameters that are useful. And I'm actually going to turn off that section plane so you see the whole thing. I see element size, element order. Again, that's linear, quadratic. And I assume it's choosing quadratic. You could select it to make sure. That's going to give you the greatest accuracy with the fewest elements. Using adaptive sizing. This is using the program to automatically decide how to adjust it. I have it turned off right now. Growth rate is how fast it's transitioned. So this would allow about a 20% variation. And I can set a maximum element size. You can have it check for errors, and you can have different limits. And way down here under the inflation, again, we have a transition ratio, maximum number of layers, and a growth rate that determines how it transitions between different element size types. Go to the help if you'd like to see some more information on that. Now, rather than using this 0.03 size element, say I'd really like this coarser mesh, and I know I don't need a real fine mesh everywhere. Let's go ahead and regenerate that. Let's see, we'll click on okay, so here's my mesh. Obviously very coarse, not likely to get great accuracy, and this is an extreme case. But I want to show you some of the things you could do to refine that. First is I could put in a mesh control, put sizing on particular locations. So if I say I expect the stress to be big around this hole, I can select that face, and I could say, well, rather than 0.25, I'd really want that to be 0.125 around that surface. And again, I have a growth rate that can determine how fast that changes. So closer to 1 means it's going to get more, it'll grow more slowly around that fine area there. So, but we'll use the default right now, and let's update our mesh. Okay. So you can see it has, to do that face shadow, it's made these thinner on this way, so I've decreased the aspect ratio, and then it's made a little finer mesh around the circumference. Right. The other tool, and I could adjust that and say I want to go to 0.06, and let's update. Okay. So again, a little bit finer, and now I've also, it's shrunk on the other dimension as well. And this goes back to how it meshes with brick elements, that it has to do both. Now the other tool, and let's just look at the stress on that real quick. I can see the stress is in the neighborhood of what I'm looking for. Now the other tool that I can use is to put a refinement. And again, I'm going to select a geometry. I'll select that middle edge, and the refinement will be how much finer it makes it around that edge. And let's go ahead and update and see what one level does. Okay, I had to toggle show mesh to get that to show up. Now, one thing you know that it used with this algorithm, now it's got a nice transition there, multiple layers away from it. But in order to do that and to have the coarse elements on the outside, it had to switch to a tetrahedral element. These are much easier to mesh automatically, but don't necessarily give as accurate as answers. So you may need more elements in order to get a good convergence with that. So let's go ahead and solve. Okay, and look at the stresses. You can see pretty similar, went up just a little bit from the last time. And you could go ahead and repeat this and say, increase your refinement, another level, and resolve. Okay, so we see our finer mesh. Again, it's just about 3 or 4 layers. We might look at that growth ratio, and if we wanted to do more layers. If we look at the stresses, we can see that that fine mesh is incorporating most of my high gradient stress regions, and it changed very little with that extra level of refinement. Now the stresses out in here are still a little bit coarse. If I cared about that, I might be able to section this and put some controls in some of these other regions to help fine-tune that stress. But that's the general process that you're looking at. And then you can always come back and look at the number of nodes to see kind of what the impact may be on the solution time.